Good evening, all of you. Today we'll go and discuss about data structures. So in day 22, we are going to discuss about pointers. So now it is day 23. We'll go and discuss about structures, data structures. So let us start the session. So I want to discuss about data structures and followed by different types of linked list like single linked list, double linked list, circular linked list, and followed by stacks, queues. These are the topics I want to discuss in data structures. So let us let us start the session. So what is a data structures? So the simple definition of data structure is arrangement of data in computer's memory. Arrangement of data or arranging of data in computer's memory is called as a data structures. Or another definition is the data structure represents the logical relationship. So it will go to represent the logical relationship that exists between individual elements of data to carry out a certain task. So with help of these data structures, we're going to represent the logical relationship that exists between the individual elements of data to carry out a certain task, or simply you have to define data structures as data structure is an arrangement of data. So arranging of data in computer's memory. So that is the definition of a data structures. Now coming to classification of data structures or types of data structures. So what is the data structures? Arranging of data in computers memory is called as a data structures. So for arranging of data in computers memory, you have to use arrays, or you have to use structures, or you have to use trees concepts, or you have to use graphs concepts, or you have to use different types of linked list, double linked list, linked list, and so on. So for arrangement of data in computer's memory, you have to use the trees and graphs. So simply the arranging of data is called as a data structures. So now the data structures can be classified into two types. So primary data structures and secondary data structures. So the primary data structures contain basic data types like it contain integer, character, float, or pointers, constants, and so on. So all will be comes under primary data structures. So the primary data structures which will go into working on basic insertions. So basic insertions, machine insertions, which will go to working on the primary data structures. Now coming to secondary data structures. So the secondary data structures is a complicated data structures when compared to the primary data structures, and the secondary data structures can be going to derive from primary data structures, and again the secondary data structures can be classified into two types: static data structures and dynamic data structures. So what is a static data structures? If a data structures uh, is used to create a static allocation. So if the data structures is used to create a static memory allocation, so then that will be comes under static data structures. So the example for static data structures are arrays. So array is a static data structures, and the structures is a static data structures. So for allocation of static memory allocation, you have to use uh, static data structures. The example for static data structures will be arrays and structures. And next one is the dynamic data structures. So the dynamic data structures, what is the dynamic data structures? So if the data structures is used to create a dynamic memory allocation, or if the data structure is used dynamic memory allocation, that will be comes under dynamic data structures. And again, this will be going to classified into two types. So linear data structures and non-linear data structures. So what is a linear data structures? So the data structures is using a sequential allocation of memory. So if the data structures is used for allocation of sequential memory, so then it is called as a linear data structures. So if the data structures not used sequential memory allocation, then it is called as a non-linear data structures. And again, the linear data structures can be classified into different types, like like it may comes under stacks, or it may comes under queues or linked list, and again it will become on a single linked list, double linked list, circular linked list, and again a circle linked list can be classified into circular single linked list and circular double linked list. So the data structures is using a sequential memory allocation. So then the data structures is called as the linear data structures, and examples are linked list, stacks, queues, all will be comes under linear data structures. And non-linear data structures. So if the data structures is not using sequential memory allocation, so then the data structures is called as a non-linear data structures. So the example for non-linear data structures is trees and graphs. So these are the different types of data structures or classifications of data structures. So I will go and discuss one by one in the next slide. So primary data structures. What is a primary data structures? So the primary data structures are also called primitive data structures or basic data structures. So the primary data structures are also called as a primitive data structures. So the primary data structures is going to operate upon the machine insertions. Like it contains basic data types like integer, float, floating point numbers, character, constants, string constants, and pointers. So all will be comes under primary data structures. And secondary data structures. So in a secondary data structures, it is also known as a non-preemptive data structures. So the primary data structures is called as a primitive data structures, and the second data structures is called as a non-preemptive data structures. So what is the second data structures? So the second data structures are more complicated data structures, and this will going to derive from the primary data structures. So and the example for second data structures are arrays, stacks, queues, records, files, linked lists, trees, graphs. So all will be comes under secondary data structures. And next one is the secondary data structures can be classified into two types. So static data structures and the dynamic data structures. So what is the static data structures? So if a data structures is created using a static memory allocation. So if the data structures is created with help of a static memory allocation, so then it is known as a static data structures. So the static data structures are arrays and structures will be comes under static data structures. And the static data structures is also known as fixed size data structures. So the static data structures is also known as a fixed size data structures. And the second one is the dynamic data structures. So if a data structure is created using a dynamic memory allocation, so then the data structures is known as a dynamic data structures. And it is also known as a variable size data structures. So whereas the static data structures can be called as a fixed size data structures, whereas the dynamic data structures can be called as a variable size data structures. So the examples are linked list, pointers. So will be comes under dynamic data structures. And again, the dynamic data structures can be classified into two types. That is linear data structures and non-linear data structures. So linear data structures and non-linear. So non-linear data structures. So what is a linear and what is a non-linear data structures? So the data structures using sequential allocation of memory. So if the data structures is using a sequential allocations of computer memory, so then the data structures is called as a linear data structures. So the examples are arrays, records, stacks, queues, and a linked list. So it's having a sequential memory allocation. So next one, non-linear data structures. So if the data structure does not have a sequential memory allocation, are called as a non-linear data structures. So the examples are trees and graphs will become under non-linear data structures. So that is about a classification of data structures or types of data structures. So if you have any query, so please post your query in the chat box. So I will try to answer your queries. So that is about a classification of data structures or types of data structures. And now coming into linked list. So what is a linked list or what is a list? So list or linked list is an ordered collection of elements. So list or linked list is an ordered collection of elements. So that's why it will be comes under linear data structures. So it is a ordered collection of elements, and each element in the list referred to as a node. So each element can in the list can be called as a node of the list, and each node contains two fields. So for example, I am drawing here. So this is a linked list. So it contains two fields. So like that, it contains number of nodes. So it contains the list contain number of nodes, and each node contain two fields. So that is a data field and a link field. So what is a data field? So the data field contain actual data of the element. So that means what is the value you are going to store in the data field. That value will be stored here. For example, the data will be 10 of node 1. So next, what about link field? So the link field contain address of the next node. For example, the address of the first node, let us assume that it is a 100. So it is the address of node 1, and let us assume that the address of the second node is 200, and let us assume that the address of the third node is 300. So now I am going to store the data into data field 10, and second field data field 20, and for third node data field I want to store 30. So now I'm going to, if you want link from this first node to second node and second node to third node, then if you know the address of the next node, if you know the address of the node 2, then you can pointing from first node to, you can pointing from first node to second node. So that means the address of the second node which will going to store into the node 1. So the address of the second node which will going to store into the node 1, and similarly the address of the node 2 which will going to store third node address. So the third node address is 300, that will be going to store into the second node. So if we know the address of the next node, then it will going to pointing from second node to third node. So in this example I don't have a fourth node, so that's why I'm going to write if there is no nodes, then you have tried null address. So if there is no nodes in a linked list, so and that last node is a last one is a last node, then you have tried null address. So the null address indicate that it is a end of the node. So like that the list contain, so it is a list. So like that uh, the number of nodes can be stored into the linked list. And similarly, the address of the first node can be stored at a head pointer. So head pointer is a starting pointer of a linked list. So it is a head. So in head pointer, which will contain address of the first node. So whenever the head pointer will point into the first node, then the address will be stored into head pointer. So that means the head pointer contain starting node address. I hope you will be understanding what I am saying. So the head pointer contains starting node address. So in this example, the starting node address is 100. So that's why I want to store the starting address into head pointer as a 100. And similarly, the similarly every node it contain address of next node. So like the first node contain address of second node, and the second node contain address of third node, and so on. And if there is no nodes, then you have to write as a null address. So the null indicate that it is a last end of the node. So that is about a linked list. So linked list or list is an order collection of elements, and each element in the list is referred to as a node. So it is a node, and it is a node in the linked list, and each node contains two fields, that is a data field and address of the next field or link field. So the link field contains address of the next node. So that is about a linked list. Now this is example. So what you have discussed in the previous slide. So this is example. So this is a node, node 1, node 2 and node 3. I have a 3 nodes in my linked list or list. So the list contains 3 nodes. So the first node contain data is 10, and second node contain data field is 75, and the third node contain 100. And next one, and the first node contain address of link field or data or next field. So the next field contain address of the next node. So what is the address of the next node here? I am writing a1 b2. So that value will be going to store into the node 1 or first node. And if you know the address of the next node, then you can pointing from node 1 to first node to second node. And similarly, the second node contain address of the third node. So what is the address of third node? So FEE7. So the address of the next node, then it will pointing from second node to third node, and so on. If there is no nodes, then you have to write as a null address. And similarly, I said that the first node address which will going to store into the head pointer. So what is the first node address? That is FB12. So that value will going to store into the head pointer. So the head pointer contain always starting node address. So by using that starting node address, you can travel from node 1, node 2, node 3, node 4, and so on. So for traveling purpose, you can use a starting node address. With help of that starting node address, you will go traveling from 10, 75, 100, and so on. So that is about a list. And here in I said that in a list or linked list, it contains different types of addresses. So that is it contain null address, or it contain internal address, or it contain external address. So the external address contain what is address which will go and store into the head pointer. So that address can be called as a external address. So that means that the starting node address can be stored into the head pointer. So that address can be called as a external address of a linked list. And next one, what is a node? For each and every node, it contains address. So that address can be called as a internal address of the nodes. So each and every node contain their individual address of next node. I mean here the first node contain address of second node, and the second node contain address of third node, and so on. So this address can be called as a internal address. And what about null address? So the null address contain last element or last node, and it will indicate that it is the end of the node. So these are the three different types of addresses. So external address and internal address and null address. So what is the external address? So the external address is the address of the first node in the list. So what is the node, the first node contain address, so that will be going to store into the head pointer. So that head pointer address can be called as a external address. And second one, internal address. So the internal address which will go and store in each and every node of a linked list except the last node. So the internal address stored in each and every node of the linked list. So that address can be called as a internal address. And what about null address? So the null address is the address stored by the null pointer of the last node. So the last node contains null address. So what is a null indicate that? Which will go and indicate that end of the list. So these are the three different types of addresses you can use it in the linked list. I hope you will be understanding what I am saying. So if you have any doubts, please ask me. So up to now, are you okay? So up to now, if you have any doubts, please post your query in the chat box. So I will try to answer your query. Now let us continue. So external address, internal address and null address. So the linked list contains three types of addresses: external address, internal address and null addresses. Now coming into types of linked list. So the linked list can be classified into three types. So single linked list, double linked list and circular linked list. And again the circular linked list can be classified into two types: circular single linked list and circular double linked list. So these are the different types of linked list. Now we'll go and discuss today about linked list, single linked list. So what are the basic operations can be done on a single linked list? So that is a creation of a list or creation of a single linked list. So creating a list. So it is one of the operation can be done on a linked list. And next one, insertion. So insertion of a nodes in a single linked list. So again the insertion can be placed in different ways. So inserting at the beginning of the linked list, inserting at middle of the linked list, or inserting at the end of the linked list. So the insertion can be done in three ways. So inserting at first node, inserting the new value as a first node, inserting the new value in the between the elements, or inserting the new node as a last node. And similarly deleting. So again the deleting will be also classified into three types. So deleting of a first node, or deleting of a middle node, or deleting of a end of the node. And next one is display of a linked list. So display or travels. So if you want travel from node 1, node 2, node 3, node 4, then you have to use these techniques for displaying of content in the node. You have to use the display operation or travels of a list in the linked list. And finally you have to count the number of nodes. So how many nodes you are going to create it, or how many nodes it will be left out after performing insertion operation or after performing a deletion operation, then you need to count. So these are the different types of operations can be done on the linked list. So creating a list, insertion of a nodes in the linked list, and deletion of a nodes, and display or travels of a linked list, and count the number of nodes in a linked list. Now coming into creation. So how we will going to create a linked list? So first one, creating a node. So after creating a node, reading the details for a node from user. So that means that you have to read the data, you have to read data into the data field, and you have to insert the address of the next node. So after that you need to connect the from first node to second node to third node, and so on. So like that we will going to create a linked list. And next one is insertion. So I said that the insertion of a linked list can be performed in three different places. So that is inserting as a first node in the linked list, and inserting as a last node in the linked list, and inserting an intermediate node in the linked list. So these are the three places you can insert the linked list values in the linked list. So this is an example for inserting as a first node in the list. So here my list will be contain 75 and 530. So it is a data field. So it contains two nodes like node 1 and node 2, and followed by the data is 75 and 530, and the first node address which will store address of the second node, and if there is no nodes then you have to write a null address. And similarly the head pointer contain starting node address. So here the starting node address is A1 B2, that will be going to store into the head pointer. So now I'm going to insert a new node. So its contain data is 10, and I don't know what is the address of the next node. So that's why I will be write null address. So after connecting this node, then I will write the address of the next node. So initially I'm going to insert the data into data field, and I'm going to insert the null address into the link field or address field. So now I'm going to connect this node before 75, that is inserting at beginning of the node. So for that what you have to do? So you can save the, in the place of null address, what you have to do? You can save the address of the next node. You can save the address of the next node. So what is the address of the next node here? A1 B2. So that address will be going to store into the new created node. So after that what you have to do? If you know the address of the next node, then it will be pointing from the newly created node to next node. So after that what you have to do? So actually in 75, the first node, it contain address of the address in the head pointer, that is A1 B2 address in head pointer. Now here the newly created address is FB12. So now in head pointer you can store that address. Okay, so you are not going to store the A1 B2 address. You will go and store the FB12 address in head pointer. So that is a simple inserting. So now I'm going to insert the linked list at first position. Before the 75, I insert this successfully. So that is a inserting at a beginning. And similarly, next one is inserting at last position. So if you want inserting a new node at after second node, then you need to travel from first node, and you need to travel from second node, and you need to travel from third node, fourth node, and so on. So in this example I have only two nodes, then I will going to travel from first node, and I will go and travel from second node. So after traveling from second node, then I'm going to insert a one new created node. So and it contain address is FB12, and data field it contain data is 10, and address of the next node I don't know initially what is the address will be. So now after inserting the last position, then it will be like this. So the address of the newly created, which will go store into the second node, and if you know the address of the second node, then it will pointing from second node to third node. And similarly the third node does not have any other nodes, that's why here you have to write null address. So this is a before insertion and after inserting at a last position. And next one is inserting an intermediate node in the linked list. So now I want to insert the data in between 75 and 530. So the new node is 10, the data it is 10, the data field is 10, and I don't know address of the next node, so it is initially null address. Now I am going to place 10 in between 75 and 530 nodes. So now this is a before insertion, and after insertion, see here. So in after insertion, what happened? So in a before insertion, the first node contain address of the second node. So now after insertion, the first node contain address of the newly created node, that is FB12, which will go and store into the node 1. And so similarly the second node, now the 10 is a second node, that will be contain address of the next node. So that is FEE7, that will go and store into the second node. So if you know the address of the next node, then it will go and pointing from third node. So here 530 is a third node now after inserting 10 in between the 75 and 530. And if there is no nodes, then you have to write the last node as a null address. So these are the three positions you can place. You can perform insertion operation. So inserting at the beginning of the node, or inserting at last position, or inserting intermediate of the nodes in a linked list. So next one, similarly deletion. So the deletion can be also performed in three places. So deleting at the first node, or deleting at last node, or deleting at intermediate node. So same thing. If you want deleting a first node, what you have to do? You can store the address of the second node into head pointer. So once you can store the address into the second node address into head pointer, then it will going to disconnected. That means we are going to delete the starting address. So this is a before deletion and after deletion. So after deletion, the second node address which will go store into the head pointer. So next one, deleting at last node. So now if you want deleting at last node, and again you need to travel from first node, second node, third node, and so on. So after traveling to the last but one node, now you can set this field as a null address. So if you set this field as a null address, then it will indicate that the second node is the end of the node. So then it will be automatically remove the connection from second node to third node. So this is before deletion, and after deleting a last node, so this will be diagram. And next one is deleting an intermediate node. So for example, if you want to delete an intermediate node, what you have to do? So simply what you have to do? So can store the address of the first node into third node address, and similarly, and similarly, uh, only that's it. So can store the address of the third node into node 1. So once you can store the address of the third node into first node, then the second node will be going to remove automatically. So that is it. That is about intermediate deletion. And next one is traveling. Traveling. So if you want traveling from node 1, node 2, node 3, then you have to use this operation. You can move from node 1, node 2, node 3, and while moving from node 1 to last node, you have to uh, display an, data fields like 10, 20, 30, 40, 50 data fields in the nodes. So next, count the number of nodes in a linked list. So this will be also to travel. We have to travel from first node, second node, third node, and so on. While traveling, you have to increment the count value, and finally you can display the count value. Then we will get the number of nodes after inserting and after deleting a number of elements in the linked list. And this is an example. So now I'm going to explain the example. So it is a linked list example program. So here I'm going to use different types of operations like create a node, append, and after that insertion operation, deletion operation, and display and count operations. So initially my starting node and last node I'm going to assign as a null address, and it is a structured declaration of a node. So it is a linked list. The structure name is linked list, and the node contain two fields, that is a data field and address of the next node. And after that I'm going to use a do I'm going to perform operations append, insertion, delete, display, and count. And after that, among these options, you have to enter the choice. So if your choice is 1, 2, 3, 4, 5, then it will go and perform appending, inserting, deleting, display, and count operation. If you are select out of this choice, then it will go and display invalid choice. So like that I want repetitively executed whenever I press a Y button in my keyboard. So Y indicate that yes. If you press a Y keyboard in a keyboard, then it will go and again repeat the entire options once again. So next one, so this is a code for creating a node. So before you want to creating any nodes in a linked list, so first we need to allocate the memory space. So by using a mlc function, you have to allocate the memory for the nodes. So here temp is a I want to use a one temporary node, or the node name is a temp. The node name is temp. Before I want to create a node, I want to allocate the memory space with help of a mlc function. I want to allocate the memory space for the temp node, and after that I'm going to insert the data into the data field. For that, what I do, I'm going to read a number from the keyboard, and whatever the number I'm going to read from the keyboard, that value will be stored into the temp. So it is a node name. Temp points to data field. So on that data field, the x value, whatever the x value you are going to read from the keyboard, that value will go and store into the temp. The node name is temp and followed by data field. And similarly, initially I don't know address of the next node, so that's why I'm writing temp points next is equal to null address, and return of temp. So like that you have to create a number of nodes in a linked list. Like we can enter the number into a data field like 10, 20, 30, 40, 50, like this. Like this you have to create number of nodes. How many nodes you want required, you have to create. So next one is after creating a first node. Now I'm going to create a second node, so that will be called as a appending operation. So appending operation. So here I'm going to use append operation. So before I want to creating a second node, then I will go and call the create node. I will go and call the create node function. Then it will go to allocate the memory for the new node, and you can read the data from the keyboard, and you can store the data into data field, and you can set it as a next field as a null address. So after that, what you have to do, if the starting node is equal to null address, so that means the newly created node is a starting node. Then you have to write temp points to you can assign temp is equal to starting node. Why? Because the list contain only one node. If suppose the list contain only one node, then you can the newly created node is a starting node, as well as the newly created starting node as a last node only. So that means the list contain only one node, then the first node is a starting node and the first node is a last node. For example, the list contain two nodes. So if the list contain two nodes, then you will go to insert at end of the linked list. So for that, what you have to do, you can travel from node 1, node 2. After that, you can write for second node last points to next is equal to temp. So you can store the temp address into last node, and after that, what you have to do, you can set it as a last node as a temp name. So like that, we will go into appending number of nodes in a linked list. And this is a code for insertion operation. So before you want inserting any operation, we will go to create a one new node. After that, you can take a position where you can insert the newly created node in the existing linked list. So this is a code for inserting at first position. So if you want inserting at first position, you can use position is equal to 1. For example, if you want inserting at after, okay, inserting at last position, then you have to use this code. You have to travel from first position to last before but one position, and you need to insert the data. For example, if you want inserting at middle position, then you have to use this code. And similarly, deletion. If while deletion operation, what you have to do, you need to check one condition whether the list is empty or not. So if the list is empty, you are not going to perform deletion operation. So that's why first you can need to check whether the starting node is null address or not. If it is null address, you cannot perform deletion operation. That is simply your display list is empty. And if the list is not empty, then you have to select the position. So if you want to delete a first position, you have to use this code. So after deleting a first element, then you have to free the that memory location. So with help of a free function, you can free the memory of a first node. And similarly, this is a code uh, for removing of a last node. For removing of last node, we will go and travel from first node to last position. And next one is this is a code for removing of a middle of the node. So and next one is a display. So for display, what you have to do, you need to check a condition if the starting node is equal to null or not. If it is equal to null, you can display list is empty. So otherwise, you need to display the data field. So what are the data contained in a data field? You need to display. So for that, what you have to do, percentage d comma 10 points to data. So in this field, it contains numbers. So you need to display that numbers. So next count operation. So initially count is equal to 0 and I'm going to check while temp not equal to null. So we'll going to travel from first node to second node to third node and so on up to the node it cannot be reached to the null node. So while traveling from first node to second node, you need to increment the count value. So after reaching to the end of the null address, then it will go into terminate, and finally you can display the number of nodes in a linked list. So that is a program. So that is a program for linked list. So let us execute this code in my Turbo C++. Okay, now I will go and open my code. So it is a single linked list. So now I am going to compile the program. So I don't have any errors in my code. Now I am going to run the program. So these are the options which will go display. First one, I need to appending. So like choice one. So the data is 10 and yes, and I will take again choice one. The data is 20, and again I am going to take choice one. I will insert one more node is 30. So now I am going to insert three nodes, 10, 20, and 30. So now I am going to display. So now I am going to display how many nodes are there in my linked list. For that, what is the option here? Display 4. So this is a output. So now the linked list contains 3 nodes. So 10 is the first node, and 20 is the intermediate node, and 30 is the last node. Now I am going to continue. Now I am going to insert. I am going to perform insertion operation, and the data is 40. So the insertion operation can be done in 3 positions. So before 10, for example, I want to insert the 40 at before 10. Then we have write a position number 1. Now press S and display immediately. Now see here. So in the previous one, I got 10, 20, 30. So now after inserting before the 10, then I got output is 40, 10, 20, 30. So that is you are going to insert the value before the 10 successfully. Now again you can perform second operation, insert, and the data is 50. Now I am going to insert the 50 after 30. So what is the position after 30? It is the fifth position. Now you can give position 5. and yes, and you can display immediately. So now see here. So in the previous one I got 40, 10, 20 and 30. Now I insert the last position, that is after 30. So it is a 50. Now press Y, and one more operation is second operation. So my data is 60. Now I want to insert this 60 in between 20 and 30. So what is the position of between 20 and 30? So that is a 40 is the first position, 10 is the second position, 20 is the third position. After 20, it is a fourth position. Now you have to give position number 4 and press Y and display immediately. Now see here. So now I got the 60 in between 20 and 30. That is the fourth position of the linked list. So that is a inserting at beginning, inserting at the last, and inserting at the middle position. So now I am going to perform deletion operation. Or before performing a deletion operation, let us count how many nodes are there in my linked list. So the option is 5. So how many nodes are there here? There are 6 nodes are there, like 10, 20, 30, 40, 50 and 60. So that's why it will go to a count value will be 6. So the linked list contain 6 nodes. Now press Y. Now you can perform deletion operation. So the option is 3. Now you can choose position number. So where you can delete the uh, values in the linked list. For example, I want delete 40. So for example, I want delete a 40. So what is the position here? That is a 1. Now press and you can give a position 1 and press enter and press Y and display. Now see here. So the 40 will be deleted. Now I got 10, 20, 60, 30, 50 only. Now press Y and again you have choose the third option. Now I want to delete a 50. So that is the last position. So what is the position of 50? It is the fifth position. Now you can enter fifth position. Now press Y and display immediately. Now see here, after deleting a 50, in my linked list will be 10, 20, 60, 30 only. Now next press Y and give third option, and now I want delete a 60. So between 20 and 30, 60 I want to delete. So what is the position of 60? That is the third position. So now we have to enter third position. Now we can display immediately. Now the 60 will be deleted between 20 and 30. Now finally I got only 10, 20, 30 nodes in the linked list. So these are the operations can be done on the linked list. So if you have any doubts, you can ask me. And finally, if you want count how many nodes are there, you can give option 5. So how many nodes are there after performing insertion and deletion operation? It contains only 3 nodes. And if you press no, then it will go to terminate. So that is about a linked list program. So if you have any doubts, you can ask me in the chat box. I will try to answer your queries. So that's all about today's class. And if you have any doubts, you can ask me in the chat box. I will try to answer your queries. So do you have any doubts? So if you like this video, if you like the today's session, so please click on a thumbs up button. So if you like this video, please click on a thumbs up button. So that's all about today's session. And if you have any doubts regarding this topic, I will try to discuss the same topic in the next session also. Or otherwise, if you don't have any doubts, I will proceed to the next topic. So that's all about today's session.